So hello everyone, we are a couple of minutes past the hour, so I think now is a good time to start. So depending on where in the world you are, good morning or good afternoon, and thanks for joining us today. So I am Tim Beck, Associate Professor of Federated Systems and Bioinformatics based at the University of Nottingham, and I will be chairing the webinar today. This is the second HDR UK Federated Analytics webinar organised on behalf of the HDR UK technology community. So the focus of today's webinar is the application of Federated Analytics in European national health data programmes. So first, some housekeeping messages. The session today will be recorded. Please use the Zoom Q&A feature instead of the chat to post your questions to our speakers, and we'll get through as many as we can at the end. So we have 4 speakers today, so it will help us to triage the questions if you can include who the question is for. Let's follow the HDR UK values during this session, and of course, please do enjoy the webinar. So we have a packed agenda today. So I will start by giving a very brief overview of the HDR UK Federated Analytics Programme. We then have 2 speakers from the Dutch Health RI programme, followed by 2 speakers from the German NFDI for Health programme. After all the talks, there will be time for Q&A, so please send your questions in as we go along. The HDR UK Federated Analytics Programme is assembling and integrating existing infrastructure to support easier and reproducible federated analytics within trusted research environments. So we are adopting and reusing international standards from organizations such as GA4GH and Elixir. We are part of international consortia, so we can learn from what works well elsewhere and share what we have developed in the UK. We are building an open collaborative ecosystem. So our aim here is to promote open development best practice across the Federated Analytics Programme and the wider HDR UK technology community. So the actual infrastructure we are developing is built on the work from 2 related projects called Teleport and Trifix. And so these projects showed how you could network TREs and run analytics across many TREs. So we are going beyond this current state of the art to integrate these approaches to ultimately provide the technical infrastructure required to support federated analytics health data research to be conducted at pace and at scale. So there are a few ways that you can find out more about the Federated Analytics Programme. So we have a mailing list that will keep you up to date with announcements. So scanning the QR code on the screen will take you to the sign-up page. There is a monthly public technical roadmap review and drop-in session that's open to all, so anybody can come along and meet the team. You can ask questions and find out more about the program. The connection details for these sessions are sent to the mailing list, so that's another reason to sign up if you haven't already. And we use GitHub discussions for technical questions. So scanning the QR code on the screen there will take you to the discussion page. And of course, finally, we organize this webinar series. So we cover a different topic around federated analytics each time. And an announcement will follow shortly regarding the date and the topic of the September webinar. Okay, so I will now stop sharing my screen to allow our first speakers to set up their presentations. So our first speakers are Anne van der Kant and Mel Ciesverder. Anne is coordinator of analysis architecture at Health RI. She focuses on bringing stakeholders together to work on interoperability and analysis infrastructure for health data, specifically federated analysis infrastructure and secure processing environments. Anne is closely involved in preparations for the Dutch Health Data Access Body and is involved in EOSCIN Trust. Mel is Senior Advisor and Chief Medical Information Officer at the Netherlands Comprehensive Cancer Organisation. He conducts research into new possibilities for using observational data for clinical decision support and shared decision making. In recent years, Mel worked as a pioneer on the Vantage 6 software for federated learning. So Anne and Mel have a 20-minute presentation on bottom-up and top-down approaches to connecting technical solutions to governance to develop a federated network for sharing health data in the Netherlands. So I give you the floor. Thank you.
Thank you so much, Tim, and thank you to both Tim and Ruth for having us here today. Indeed, we are, well, this is a common effort and trying to here bring together the efforts that we have in HealthRI that is in itself bringing together different infrastructures and then talk from one infrastructure that is already quite far in using federated analytics in practice. So first I want to start with the mission at HealthRI. What are we trying to achieve? We are trying to achieve better healthcare for citizens and patients by reusing health data with an integrated health data infrastructure for research, policy, and innovation. And I start with this mission because it's an important reason why we would need federated analytics, because at the moment, the data of the individual hospitals or individual healthcare organizations is not always available for reuse. Yeah, putting barriers in place for reaching this better healthcare for citizens and patients. So how are we doing this in HealthRI? We are working with a network of 8 regional nodes, which are mainly focused around university medical centers. And in the case of Eindhoven, this is a university and some hospitals in the area, and also a company. And the function of these regional nodes is to actually make the data available from the region for reuse, and also to build a network of trust within the Netherlands to share data and collect insights. And this trust is a very important point for setting up a federated analytics infrastructure. So at these regional nodes are connected by a central hub in Utrecht, where I also work. And here from the hub, different working groups are coordinated where the regional nodes participate to develop different parts of the infrastructure. So for both making data available at the source, but also for the users of data and for making data findable. So I'm coordinating the analysis working group, where we work together with representatives from the different nodes, but also organizations like IKNL, where Melle is representing, to work on data analysis infrastructure. So there are some central services that we want to develop at a node for about finding the data, requesting data access, and also for data analysis. And today we will focus on the data analysis. In a node, we're working on both central data analysis, for example, secure processing environments, and federated data analysis infrastructure. So what is the problem here? Mostly in the Netherlands, it's fragmentation. So technically, this federated analysis already works in several use cases. But different organizations and different collaborations that use their data together use different implementations. And it takes a lot of time and a lot of effort to build a new collaboration, to build a new trust network, to start a federated analysis. And what we are trying at HealthRI is to make this easier and make this faster. So the figure on the left is showing actually the Dutch version of how this works with the water. So many years ago, well, not that many, 100 years ago, individual houses would protect themselves by building their houses on a mound. But these are individual solutions. And at some point, there was a big disaster, and the Dutch government decided we need a big plan to actually bring efforts together. And they built the Delta Works. So what we're trying to build is the Delta Works of data collaboration, but not only with federated analysis, but it does apply here as well. So this is not mainly a technical problem. If we want to build an interoperable, scalable, and integrated infrastructure for federated analysis, we also need a lot of agreements. So on standards for the infrastructure, or how to use the different standards and the data. We need to agree on which algorithms we trust, and how do we assess which algorithms different data users trust. How we need to agree on legal agreements and on how, who is going to pay for, among others, the compute, also for the infrastructure, and how do we organize this between partners. So we try to achieve this by working together with initiatives that are already existing in the Netherlands, because we don't want to build a new network from scratch when the technology is already there, and when there are also already some trust networks. So we try to build, to integrate, to build a bigger trust network in the Netherlands, with an accompanying set of agreements and also shared services. So on the level of agreements, this could, for example, be framework contracts for predefined analysis. So if you have specific data sets where you agree that certain simple analysis can already be run out of the box without going through the whole legal mill again, and without setting up the contracts from the beginning, this can save a lot of time. Also agreeing on standards and agreeing on who invests and how the payment is organized. From the node, we are trying to set up shared services that can actually, or from the hub, we are trying to set up shared services that can support this network. This can be a support network of service desks, so that a researcher who works in a certain hospital or in a university hospital knows where to go if they want to start a federated analysis. Sharing templates of contracts, and also starting to develop a harmonized access request, algorithm repository and auditing process to standardize what algorithm we trust, and also identification, authentication, and authorization solutions that are usable in the whole network. So what should this look like? The data user wants to, in the end, reach a data station or a data set to do their research. So first there is a loop to prepare for this. The user might go to the service desk, access, put in a data access request, organize the contracts, get a cost indication, and start the auditing process for their specific algorithm. See? Yeah, for this, of course, they have to send the algorithm to a container repository, which is included in the auditing process. then the researcher can start the actual analysis loop by accessing a central server, accessing then a data station through a station directory and starting their analysis. But this preparation loop actually takes a lot of effort, and the analysis loop will be highlighted more, I think, by Melle, who I will give the floor now. So I will stop.
You want me to
sharing.
take? Oh, sure. I'm sorry. If you can stop sharing then. Hi guys. I'm not sure how much time we still have, but this is should start at the beginning, right? Very briefly. Hi, my name is Melle. I work at IKNL, Netherlands Comprehensive Cancer Organization, and I wanted to talk to you about why we are working on federated learning. And I think we can summarize that by saying we want to reduce the impact of cancer, and we want to make sure that we have the data that we actually can do research on to reduce that impact. So currently we have manual data entry that doesn't scale, especially if you now have 135,000 tumors per year, with a growing incidence rate and with a growing need for access to data. So we need something else, and that something else you can imagine is federated learning. I will skip most of this because I think a lot of this is already known. Of course, you in the UK have the advantage of having a single healthcare service provider, but I'm still not sure whether EHR data is standardized in the UK. I'm guessing no, but in the Netherlands, it's definitely not, and we need to do some work there. So what we're currently working on is Plugin, and Plugin is short for Platform for Reuse and Exchange of Clinical Data in the Netherlands. It's a platform that tries to make reuse of clinical data possible and easy by basically taking EHR data, which is the pictogram here on the right, which says EPD, which is EHR in Dutch, turn it into FHIR data, which makes it computer accessible and readable, and then unlocking that data with Vantage6. Jim, how much time do we have?
Another 8 minutes.
Oh, 8 entire minutes. Oh, that's enough. Cool. So the plan in 2 sentences is basically to implement what Anna was talking about, right? We want to standardize EHR data using FHIR, use federated techniques to provide access, and then you will have a single data model for all or at least multiple applications, and you have a scalable, secure, privacy-preserving way to use that data. And you can use that for basically anything you can imagine. You can use it to develop management reports, to do research and development of AI models. You can apply large language models to clinical data if you want. You can learn large language models using clinical data if you want. You can even use it for data exchange, which might not be federated learning really, but if you can, why not in some specific, very specific use cases where everybody trusts each other. So basically, we're looking at a decentralized approach. And well, I think this part is already known, right? You guys know what federated learning is. So if I show you an example where you can average the age of 3 partitions, then that's probably easy, right? What's generally not so easy is the fact that you need to standardize the data. So if you want to calculate an average on site, you need, for example, age to be in years and not that somebody does it in days. That would be confusing. So how do we do that? Technically, we're using Vantage6. So I think Andre Dekker presented a while ago about Vantage6. So I'll be really quick about this, but it consists of 3 components, maybe 4, depending on how you look at it. It consists of a researcher, somebody who's interested in using the data. It consists of a central server, which acts as a communication relay or liaison. And it consists of nodes. Nodes are pieces of software installed on site. The researcher can ask questions to that central server. The central server makes sure that whoever is talking to it is authenticated and actually allowed to do what it wants to do, does not calculate stuff. And the nodes are basically the gatekeepers of the data. The nodes are connected to the data source. Now, as I mentioned earlier, standardization is important. So every node needs to be having the data in its same format. And we're using Fire to accomplish that, which doesn't solve everything, but it solves a lot. Here so far? Cool. If not, feel free to raise your hand and ask a question. Oh, no, sorry, you're using the questions and answers. We'll do the questions afterwards. To make this flexible and reusable, we're using containerization for the algorithms. So basically, we're sticking everything that we need to compute in a tiny miniature computer called a Docker image. We're distributing the Docker image to the nodes so they all know what to do. Nodes run the Docker image and nodes are returning the results. So why do we do that? It makes algorithms operating system independent. It solves dependency issues. So if one algorithm uses Python 3.7 and the other one 2.7, which is really ancient, but still, you can do that if you want. You shouldn't, but you can. It also provides isolation from the host OS. So it's reasonably safe, and it provides isolation from the network. So your algorithm, unless you specifically allow it to, cannot send its data to China, which I think is a good thing. Makes it also very easy to deploy. The node only needs to know Docker and accept Docker images. Technically, we support a couple of other containerization options, but I think Docker is the most common, or at least most commonly used. Yeah, for those of you who are interested in how that works or what Docker is and does, you can run it from the command line. And if you have it installed and you run, for example, Docker run hello world, basically what it does is it downloads the algorithm or thing that you want to run from a central repository. So in this case, it downloaded it from Docker Hub. It gives you the output of that algorithm and it returns the result. Yippee. So if you make that a little bit more complex, what would that look like? Say you have a Cox regression, which is not the entire formula, but a part of it. The researcher would send a communication request to the central server. That would contain the algorithm, the URL to a Docker image. That gets distributed to the nodes. The nodes calculate their parts in the complete formula and they return the aggregated results, which makes things very easy and safe. To make things easier and safer, we also developed PlugNML, which is basically a library that runs on top of Fantasy6 and allows you to use all kinds of federated and non-federated types of analyses in a very easy way. It's based on scikit-learn. Works like a charm. It's not open source yet, but will be very soon. So summing it up in 2 sentences, technically it's fairly easy. We're just standardizing data into Fire and using Fantasy6, and then we're very, very happy because it allows us to do a lot. Yeah, this is another way of putting that, which I probably could have left out, sorry. Why are we using Fire? Because it's an international standard, because it's used in healthcare, in hospitals. So rather than OMOP, which is very much used for research, this is actually used by doctors, well, by the systems that doctors use. And it helps us with both structure, content, and it helps us with a technique for data exchange. So the HTTP protocol is part, HTTP API is part of the definition, which makes it very easy to use. Fire breaks things up into nice units, resources, and that's the other advantage that you have, is that you can standardize per resource. So you don't have to do everything all together at once. You can just say, okay, we're starting with this tiny portion of the data model. For those of you interested, have a look at the website. It's all open source. It's very lovely to look at. It's easy to read. There's even a Dutch version, which is partially developed by Nicholas and Nations of the Netherlands, which aligns with national developments and is very compatible with all the standards where it needs to be. Specifically for plugin, we're also developing an implementation guide. I guess that's very Dutch specific, so not very much use to you, but should you be interested, feel free to have a look. And that brings me to the fact that it actually works. We did this at one university hospital, LUMC. There we developed a dashboard for palliative care, which allows us to visualize information like location of death or the number of ICU admissions in the final 13 days before expiration. So yeah, I think this is basically the premise, and we're trying to show that it works by using for specific use cases, which this is in Dutch, but this is English. I think the one on the bottom left is the one that we're looking at. We're trying to populate the Netherlands Cancer Registry. We're having a pilot for that running, and it seems to be going very well. In summary, yeah, I hope you can see the animation, but this is what it would look like roughly. You can send out information, get the results back, and everybody who's interested and allowed to use this should be and will be, hopefully, in the very near future. I think I made it in time, right?
Perfect timing. Thank you. Bang on 20 minutes. So wonderful. Thank you very much. So just a reminder to the audience to use the Q&A feature to send in your questions, and there will be a Q&A session after all of the talks. So we now have two 10-minute presentations from NFDI for Health. So Toralf Kirsten will present NFDI for Health and the personal health train. Toralf is Professor for Medical Data Science at Leipzig University. He is interested in infrastructures for medical data analysis and medical decision making, and the analysis of medical data with statistical and artificial intelligence methods. This will be followed by a presentation by Katarina Nimsch, who will present on Data Shield in NFDI for Health. So Katarina is a scientist in the Molecular Epidemiology Research Group at the Max Delbruck Center. Katarina has a master's in nutrition and epidemiology, a PhD in cancer epidemiology, and postdoc experience at Harvard School of Public Health. So thank you. I give you the floor.
Thank you, Tim, for this invitation and the very kind introduction. In the beginning, I need to say that you currently have heard about the Health RI, which focuses on clinical data, sharing clinical data. The NFT for Health is focused on sharing clinical study or clinical trial data and epidemiological study data. We also have in Germany a large initiative which is called Medical Informatics Initiative, which also focuses on sharing clinical data. So we also came together last year with Health RI to exchange some ideas in the current state. But now I would like to talk about the NFDFHF consortium. And again, the personal health train. I can make it a little bit shorter. So for the motivation that we see, there are different clinical trials, many epidemiological studies and research projects that are executed yearly. And you probably have no knowledge about all the clinical trials that are executed, epidemiological studies. You only know or you get only knowledge about that by publications you read about that, or you have a look at more detailed in registries like clinicaltrials.gov. But this is only true for clinical trials, which needs to be registered, and you can then search and find that. But the case is that the data use is often very unclear, because it's not really clear how to access the data, how to in which format the data are, and what you can do with the data. Often it remains in your personal network. You can contact anybody, and then you can maybe access the data or get access to the data that have been collected somehow. And therefore, and this is not only true for the health domain, but this is also true for other domains. Of course, every domain, every scientific discipline has its specifics. In Germany, therefore, we started an initiative, an Germany-wide initiative, which is called National Research Data Infrastructure, or short NFDI, which is for all the scientific disciplines, or for most of them. And so that means there are also disciplines included like physics, mathematics, biology, and so on. But there are specific consortia founded for the health domain. So, for example, the German Human Genome Archive, GHGA, or the NFDF for bioimage, which focuses, as the name already says, on bioimages, and the NFD for health. And the focus, as I already mentioned, that is in NFD health for health for the clinical trials and epidemiological studies to make that the studies fair. So that means findable, accessible, interoperable, and reusable. We started in 2020 with this consortium. It's a 5-year funding, and right now we are currently writing a proposal for the next funding period. The setup is like in Health RI, a distributed setup. So that means we have different data holding organizations or the study center that collect the data. Is associated with a so-called local data hub. And a local data hub basically collects the metadata about the data that is then that has been collected somehow. And in this local data hub, we collect the specifically for the data, some metadata. What is the PI, or who is the PI? What is the reason? What is the disease, perhaps, and so on. And all this kind of metadata, we have a common metadata model, of course. All this kind of metadata is then pushed to the so-called Health Study Hub. And everybody who's interested in searching for clinical trials and epidemiological studies can use this Health Study Hub to search for such studies of interest. And if he or she finds some of interest, then there's a central access point, and you can, as Anna already told you, run the governance process. You need to request the data from the different studies, and then you get perhaps access to that. And the question is how to get access to the data. And there are two modes of operations. One is a centralized data analysis that is, let's say, the old paradigm. Bring the data to the analysis. So this, the data needs to be moved to a central place where it can be analyzed, or the distributed analysis. And this is another paradigm, the vice versa paradigm. Bring the analysis to the data. We currently think about a third mode of operation, which is called trusted research environment, which is basically a secure box where you can leave your data as a data provider, and the scientist can access securely this box and execute his or her analysis on the data. We created or we used two infrastructures for distributed analysis in NFT Health, which is the personal health team. I'm currently talking about that, and Datashield, which Katharina will introduce in the next talk. And of course, there are different advantages that comes with these infrastructures, but Melle already has introduced these advantages, like the data provider keeps the control over the data. That means there is the data sovereignty that is kept successfully. Of course, we are GDPR compliant. No data leaves the border of a study center, and there, of course, there is no need to transfer large data files. If you think about MRI images or CT images or genomics data in that way. The personal health train, it's a little bit a repeat of Melle introduced in the beginning, is basically that there are stations, and the stations are referred to data providers. So each data provider needs to install a station, which is basically a small amount or small thing of software that allows you to access the data directly. So you do not have direct access to the data as a scientist, but this kind of software allows you to connect your analysis with the data at your location. And of course, you need a connecting infrastructure, the personal health train infrastructure that takes the trains, and the trains are execution environments plus the analysis scripts or programs that should be executed on the data. And perhaps there are also some intermediate results that are packed or packaged into the train. And the train is basically a Docker, and Melle has already mentioned that or introduced that in the previous talk. So what we do in Energy for Health, we create the local data hubs at each study center. And then we associate a PhD station at each local with the local data hub at each study center. And then you can have direct access to the data, direct access from the PhD station, not direct access from the scientist view of point of a researcher. But there should be, of course, a communication between the researcher and the data steward at each location, at each study center, so that the researcher is aware of what kind of data is available at the local data hub, and not only what data, but if there are outliers and so on, you can then communicate it directly to the data steward. The personal health train comes with security by design. We encrypt the data in the analysis scripts, programs at the transport level. So it's not possible to get access to intermediate results and your analysis script, and to modify that during the transportation. And of course, there is only a pull mechanism. Pull mechanism means a station cannot push a train to another station, but each station needs to pull the train. So that means the analysis container to the station itself. And there are two modes of operation for the personal health train that we use, which is the incremental and federated data analysis. Incremental means there is a sequential way in which the study centers are met by the analysis, and you can push your analysis to study center A, and then you create a model or a frequency table or whatever you want, and then this intermediate results is available to the study center B using the same algorithm, and but using a different data portion, the data portion of the study center B, and then you can update your model or your frequency table, and the final table or final model is then made available to the researcher. And the federated analysis is runs the algorithm or the analysis in parallel at each study center, and then there is a result component called result aggregator that takes the different results, aggregates them, and then you can also create a final model out of that. We have a workflow. I do not go into the detail too much. Of course, you need to register with each data provider. You need to log in, all this kind of stuff that Melle already introduced to you. Later on, you can upload your analysis, and when the train is started, of course, you need to specify which station should be included in the analysis. And at the end, as a researcher, you can find the results in the central component. Just to outline that, there is a registry. We call it a station registry, which basically manages all the station, an overview about all the stations. You can onboard your own station there and make your data that you would like to provide to the community or to a specific, let's say, set of friends available. then you can participate in the analysis. Then a common problem is also how to write the script as a researcher when you do not have a direct access to the data. And we come to a solution which is called a playground, which allows you to upload so-called test data. You see on the left-hand side, let's say a data scheme, a relational data scheme, and upload some test data, and that for each station you want to provide there. It's also, let's say, a simulation, you can call it. And then on the right-hand side, you see a script that you write according to the data, and you can always execute the analysis and simulate the analysis using the test data, so that you are pretty sure at the end that your analysis is at least syntactically correct. Of course, you need to then take into account what happens at each station if there are outliers and so on that are not reflected by the test data for sure. This is a user interface which is available at the local station, and the administrator at the local station then can pull the train, the analysis train. They can accept the job, so the job is then carried out, or reject the train. So that means the train goes over the station and will never execute the train code using the data that is available locally. Of course, at the end of the analysis at the station, it should be possible that the administrator, the local administrator, should have or could have a view into the log file just to see what have been executed, if there are something that goes wrong, and so on. But also at the same time, it should be possible to access the results, even there are images and plots you have generated during the execution, or tabular results or models that you save for later reuse. And then this kind of data is pushed to the central node, to a central node from which the next station can pull this train. And here you see the web interface for the scientist. If a process, the train is finished, then you can download all results, the final results for sure. You also can monitor the whole process. You see if an error occurs. You can also interact with that and adapt your code according to that. We have used the personal health trend in different use cases. I do not go into the detail in each use case, but you have seen we have used it for different use cases, clinical data, study data, but also images that are available at different places, different locations. And please let me know if you have any questions according to that, so I can explain it in more detail. And thank you, and yeah, I'm open for questions after Katharina's talk.
Okay, I'll take over. Can you see it in presenter mode or presentation mode right now?
Not in presenter mode yet.
Swap. Now better?
Yes.
Okay, perfect. Okay. So thank you so much for the invitation and for the possibility to talk here. So I want to introduce to you the data shield services that we offer in NFDI for Health. And I also would like to start with the motivation. So I hear that the audience here is a technical audience. So I'm personally not a technical person. I'm a nutritional epidemiologist, so I'm dealing in my research with questions such as, is sugar intake related to a higher risk of colorectal cancer, for example. So the question is, how can we reach firm conclusions in epidemiology? And if we look at the pyramid of evidence, so for epidemiology, we rely mainly on cohort studies or randomized controlled trials. And then the top of the pyramid is usually systematic reviews and meta-analysis. But these have literature-based meta-analysis have certain limitations, so we cannot perform more refined analysis. If the original studies have methodological flaws, we cannot overcome those. And we often see heterogeneity of the published data, which also may be related to different definitions of comparison groups and different adjustment models. So these are all things that we can overcome with joint analysis of individual level data. So this should be even on the top of the literature-based meta-analysis in the pyramid of evidence. So with the joint analysis, and I think I don't need to go in detail here, so we can answer complex questions where the individual studies may be underpowered to examine. It offers us the possibility to reuse data in new ways, and it increases also the diversity of samples and the robustness for subgroup analysis. And we can distinguish between a pooled analysis that was mentioned before already, so where we physically transfer data and put it in one single central database, or the federated approach where we can still conduct individual level data analysis, but without the physical transfer. So, so I'm talking here mainly about observational and epidemiological studies, and especially for ongoing cohort studies, physical data sharing is often difficult due to data protection and IP rights. So here the direction of federated analysis seems a good solution. And also in these various studies, we have a variety, a huge number of exposure and outcome variables. So we also need metadatabases to plan research projects. So I'm talking about DataShield. So DataShield is an open source software that facilitates federated analysis, and it works in a way that the data holding organization store their data sets on an open server. And so the data stays basically behind the firewall, and then an analyst can connect to the DataShield client and then run analysis with specific DataShield client packages that make sure that the aggregated results that are sent back are non-disclosive. So it's a flexible way to analyze individual level data, and the data stays strictly secure. It works with distributed computing and parallelized analysis. And what is important for us researchers is that it's really mathematically equivalent to a meta-analysis of pooled harmonized individual level data. And we have worked in previous knowledge platforms, and so we gained some experience with DataShield. And in the end, it really we were able to run federated analysis on multiple studies and also publish the results. So we already have positive experience with that. And in coming to NFDI for Health, here we have a variety of epidemiological studies and public health studies all over Germany, local studies with a large number of participants, but also the narco health study, which is the largest ongoing cohort study in Germany. And we also have clinical studies, registries, and administrative databases. So this was shown by Thoralf before, just to highlight what I mentioned before. So we need a metadatabase to plan our research projects. So we have the Health Study Hub, and the link is already in the chat, as I saw. So here researchers can go and find out which studies are eligible for their specific study question. And then on the other hand, we offer this federated data analysis server for the federated analysis, and for the data holding organizations, which is here, they then have a federated data analysis node. And I also want to mention here that we need for running federated analysis of multiple studies, we also need harmonized data. Oops. So in NFDI for Health, we have use cases that have the purpose of testing and implementing the service infrastructures that are being developed in NFDI for Health for various research areas. And then within these use cases, we have pilot projects of typical research questions. So for epidemiological study data, we have a use case in nutritional epidemiology and one in chronic disease epidemiology that we run here at the MDC. So, and then we have pilot projects within these use cases. So in nutritional epidemiology, we have a pilot on dietary patterns. And in chronic disease epidemiology, we want to investigate the association between dietary sugar intake and prospective changes in body fatness and chronic disease risk. And in the table on the right, you see the studies all over Germany that are participating in these use cases. And you also see the progress in terms of metadata collection, variable level metadata collection, and then the installation of the data shield environment and data harmonization, which is currently ongoing. And so these federated analysis projects have several steps. So one is collecting the metadata, and the other one is to set up the data shield and Opal environment. So the Opal server needs to be installed at the data holding organizations, an R server with the data shield packages and a database engine also. Then comes the data harmonization, and then the data holding organizations participating in the pilots upload the data dictionary and the harmonized data set on Opal, and also they need to give permissions to the analysts, and then the analysis can be conducted. So just a few words on the data harmonization. So for this, because this is also a big issue, we set up a data harmonization protocol, which is based on the Malmström methods. So we are using their R package harmonize. It's a semi-automated data harmonization. And this is the data shield architecture in NFDI for Health. And I'm referring here also to Sophia Ciampani, who is also in the call, who was responsible for for putting this actually into practice. So in comparison to the picture I showed you before for data shield, the difference here is that we work with a central R server, which is hosted at MDC. So the analyst is not directly connecting to the data holding organizations via data shield, but logs onto the central R server. And then if he has permission to work on the data, then through the central server, he or she gets access to the data sets and then gets the analysis results back, the aggregated results. So we have so far various data shield nodes for most of the studies that are included in the pilots all over Germany. And so finally, what we offer in NFDI for Health is services on the one hand for the data holding organizations. So we have set up comprehensive standard operating procedures that give instructions how to install and configure Opal and Data Shield, how to import data on the Opal server, and also user management and giving access to the analysts. And then for research analysts who want to conduct a federated analysis, we have a protocol and starter R script to help with the analysis. And also within NFDI for Health, we've been working on several functions to improve the analysis capabilities of Data Shield and to help researchers and make it easier, such an analysis. And for both, we offer troubleshooting support. And finally, coming back to my motivation, so the ultimate goal is that we want to facilitate the reuse of existing data from epidemiological, but also other studies, and we want to provide the necessary tools and support for federated analysis. But the ultimate goal is to answer important research questions and to bring epidemiological and other research forward. And with this, here are the references that I mentioned, and also the the protocols and SOPs published on GitHub. And with this, I thank you for your attention, and I'm looking forward to questions. And I'm trying to unshare. Okay.
So thank you very much to all speakers for wonderful presentations. I can see as well that the speakers have been very busy in the Q&A feature, answering a lot of the questions. And I think we have one outstanding question, I think, which is, it looks like it's currently being answered. I just have a quick question for, I guess, both programs, and that's around the use of GA4GH standards. So unless I've missed it, I didn't hear anything around the use or potential use of some of the data security standards, or the research identity standards, or the regulatory and ethics standards that GA4GH provide. And I just wonder if any of these are on the roadmap for consideration within your programs over the coming years. So I guess that's maybe a question for maybe Anne from Health RI. I'm not sure if you want to take that.
Well, Tim, they are certainly on the radar. So not specifically for federated analysis, but more in general for the ecosystem. I'm also involved in projects surrounding identification, authorization, and authentication. And there we certainly have those standards on the roadmap, and we also try to see how we can practically and within our requirements connect the largest user groups first. So that would first be researchers, and specifically for well, the passports and visas, there are still some interoperability issues that we're working on with SURF. That is a party that provides a big infrastructure for IAA in the Netherlands for researchers specifically. So it's certainly on the radar, but if that would be fully the basis is not yet determined.
Thank you, Anne. And then I guess over to maybe Toralf can answer that one from NFDI for Health.
Yes, for sure. As Anne already mentioned, that this is also true for Germany. We have a German research network, and then you can share your credentials or can use your credentials to access other infrastructures from any site, from any university site. And we are currently also working on including the consents, which are basically only on paper, and make that electronically available, so that we are able to include that in all the, let's say, queries about the data, and then we can decide which kind of data are accessible in which way.
Wonderful. Thank you very much, everybody. So we're nearing the end of our time for this webinar. We will try to carry on answering any remaining questions offline, and then they will be circulated to the attendees. But that just leaves me to thank everybody for joining, and we look forward to seeing you again at the next Federated Analytics webinar. So thank you and goodbye.